All right, welcome everyone. This is lesson 5-7 questions. In class, we did this in groups, working together on them kind of collaboratively. Um, Here we go. First one is probability review. It says we've got Tyler being a 90% free throw shooter. His basketball team is down by 3 points. At the buzzer, he gets fouled on a 3-point shot, meaning and he misses, and he'll take 3 free throws. And then he's going to try to tie the game if he makes all 3. So what's the probability he makes all 3? That would be he makes it, he makes it, he makes it, he makes it, and he makes it, and he makes it, meaning you multiply all 3.90 to the third power on your calculator. You can pause the video and crank that out. That is 73% roughly. How about what if he just gets all tight, freezes up, and he misses all of them? That's a miss, and a miss, and a miss. I like to say and. If you find yourself saying the word and, it means you multiply the probabilities together. Now, this 10%, where did it come from? If he makes 90%, these two are linked. They are complements. He misses 10%. So multiply those out and you get a very small, 0.1%. So it's very unlikely that he will miss every single one. All right, number 2. Let's say the probability that I hand out candy on any given day of school is 20%. I'm also going to add in here, let's assume independence here, which is important, meaning that if I gave out candy today, it does not change the likelihood that I give out candy tomorrow, which is fairly true. I've done it in back-to-back days. But we're going to say they're independent events, which allows me then to just use this formula, right? If I want two things to happen back-to-back, because this symbol, again, means and, right? If I want them to happen in a row, you just multiply them. So what's the probability I gave out candy 2 straight days? Well, that would be candy and candy. So 20% times 20% is only 4%. Did I do that right? I don't know why I'm not trusting myself right now. 0.2 squared. Oh yeah, 4%. Bam! Okay. Next one. In a 5-day stretch, find the probability that I give candy at least one day. Okay? At least one day. So I like to, again, write out the sample space. Let me just backtrack on these so that, and I'll go through it. This is the sample space, right? Either I give candy out 0 days out of 5 days, 1 day out of 5 days, 2 days out of 5, 3 out of 5, 4 out of 5, or 5 out of 5, right? So what I'm going to do here is I'm going to actually find what is the probability that I never give out candy. That's the first thing I'm going to do. What's the probability of 0 days of candy? So I've done that here, candy for 0 days. So this would be with a superscript C, right? Means no candy, no candy, no candy. They all have the complement notation. So this is 1, 2, 3, 4, 5 straight days, no candy. And the probability of no candy is 80%, right? If I give candy out 20% of the time, well, then the complement of that is 80%, okay? So 0.80 times 0.80 times 0.80, 5 times over, and it turns out to be 33%. Now, I did round this a little bit, just in full disclosure, 0.80 to the 5th power, 0.327. So I rounded it to 33, all right? So that means what I have down here is that the probability of this outcome right here is 33%. Now, if I can just start to ask myself, well then, what is the probability of all the other ones? And this, doesn't this represent at least 1 day of candy? Right? It does. It's either 1, 2, 3, 4, or 5 days of candy. So that is what I was asking, right? Give candy at least 1 day. candy greater than or equal to 1 day. So what I'm going to do is I'm going to do 1 minus this, the probability of candy never. So that would be 1 minus my 33%, which is 67%. So this green box is 67%, right? If you look at these, right, the red and the green are complements because they, one of them has to happen, okay? So there you go. Now we're moving on into the counting questions. If you go to Dunkin' Donuts, maybe you get their donuts, but they have coffee. And they have way too many options. Well, they have a lot of options. They have 4 sizes of coffee, 7 different dairy options, like maybe oat milk, skim milk, whole milk, etc. 8 flavors of coffee, and then 2 sweetener. So maybe natural sugar and then artificial sugar. How many different ways can someone order a coffee? So what you do is you think of every single decision that you're making. You have to choose your size, you have to choose your dairy, choose your flavor, and choose your sweetener. And you simply put in your options into each, the number of options for each decision. So there's 4 sizes, you saw, right? 8 dairies, 7 dairies, 8 and 2. And all you do is you take your calculator out and you multiply those through, okay, to get 448. So when you step up to the counter, that's how many different things you could order. This is called the multiplication counting principle, okay? To find the total number of ways to do something, to do a process, multiply the number of options for each step. Okay? And that's what we just did, right? We had 4 steps in this case. We had size, dairy, flavor, and sweetener. Okay. Now, this one. How many different ways can the 4 teams finish the season in the NFC North? That's the NFL, the football. In the standings, okay? The teams are the Vikings, the Bears, the Lions, the Packers. We're going to assume that they can't tie. Okay, it says draw a big tree diagram. So I've drawn the whole thing here for you. I would really, really encourage you to pause the video and try to draw this without looking at this, okay? See if you can handle this and figure this out. When you... Oh, whoa, what happened? Come back. My directions disappeared. That's weird. Strange. What did I do to make them go away? Come back. Huh. Well, that's going to make things interesting. Maybe I'll pause the video or stop here and I'll make a second video, I guess. I'm trying to back up. Nothing's working. I broke it. Let's see, did I move this on top of something? No. Okay. Well, folks, I'll be back with part 2.